Roughly 2 years ago, a lady named Eva came into our office. Our office is a 3D printing center with several 3D printers capable of printing almost anything, starting from an iPhone case to a complicated educational model for medicine and even end-use parts for airplanes. Eva asked if we could 3D print her 6-year-old son a prosthetic hand. She had seen several examples online. They look much like this one. They have 3D printed fingers, 3D printed palm, and they work by using basic mechanics. For us, this task looked like a piece of cake. Richards needed the prosthesis because he's missing fingers on his right palm. The non-scientific explanation to that is he did not develop any fingers while he was in his mom's womb. When we started our work, we looked for free designs online, and sure enough, we found several that could be downloaded and 3D printed right away. However, at that time, we had completely no experience. We didn't know how to take the correct measurements, we didn't know actually how to 3D print the prosthesis, and we also forgot to nail down which of his hands he needs the prosthesis for. But luckily for us, Richards and Eva were very open-minded, and they were ready to learn together with us. So we started our journey. One of the first problems that we encountered was that it's almost impossible to scale down the prosthesis to a size that would fit the boy. When we got the limb right, the palm was too big, the fingers were too long, and so on. To get to the first assembled prototype, it took us several scaling rounds, tens of 3D prints, and at the first fitting, the prosthesis was so off, I felt ashamed. I felt ashamed especially because I knew that Richards has promised to show the hand off to his friends next morning in the kindergarten. Take a look at your own hands. They're one of the most complicated structures in your body. They're truly individual to each of us, and it's no wonder the generic design of the internet didn't really work for Richards. We needed several integral changes to the design, so we were back to square one. But after almost 2 weeks of work, we were done with the design, and it actually fit very well. For the first time, Richards was able to hold a toy. When I saw it, I was blown away. Do you even remember what was the first thing you held in your hand? Seeing how this simple device can return some of the basic functionality to his hand made me understood how helping people like Richards can instantly improve their lives. And the key to our success, it was customized design. For a moment there, it felt like we have cracked the code. Now we'll be printing prosthesis for everyone in need. However, when we look back at what we did, we helped one person over the period of 2 weeks, and it's far too long to help many people. So to understand how big a problem this is in the world, we did some more research. Obviously, Richards is not the only guy who needs a prosthesis like that. And missing fingers is just one of many problems that could be solved with the help of 3D printing. Just to paint the picture, here are some of the numbers. Globally, every day, 177 people are born with a similar problem to what Richards has. If we take a look at the year, that's already 65,000 new cases, and that's only for upper limb deficiencies. If we add other diagnoses to the mix, other diagnoses that could be helped with 3D printing supportive devices, suddenly the numbers look much different. In Latvia alone, roughly 15,000 people could be helped this way. If you take a look at the USA, that's already 2 million. In Europe, there are 4 million people with limb deficiencies that will need supportive devices. Globally, nobody really knows. But we think it's way above 50 million. And vast majority of them live in countries that have limited or no solutions available. Apparently, the problem was much bigger than we could comprehend. We started thinking, what would it take to help everyone in need? Not even looking at the conventional ways of producing a prosthetic, let's look back at what we did to help Richards. First of all, we took measurements, We did some 3D modeling, we 3D printed and assembled the prosthesis, and for this to be possible, we needed him over for several fittings, for repeated tests, and evidently, the repeated process of manually collecting these measurements and remodeling the 3D design over and over again is what took us most of the time during the period of 2 weeks. Working with our second client, Janis, we tried to streamline the process as much as possible. We replaced manual measurements with 3D scanning. We used our previous experience to incorporate this 3D scan in the modeling process, thus decreasing the time needed. It took us only 2 hours to complete the digital manipulation. Another 6 hours were spent to 3D print and assemble the prosthesis. And also, we did not need Janis over as many times because we had a 3D model of his hand. All the process was done in 1 day, which is a huge improvement over the 2 weeks that it took us to help Richards. But still, it doesn't come even close to helping everyone in need. How do we connect all those people who need supportive devices with the 3D printers out there? How do we bridge this? How do we make a customized 3D design of everybody's problem? If we would ask a professional 3D designer to help us, and knowing it takes around 2 hours to help one person, that designer could help almost 4 persons a day. In a month's time, that could go up to 80 persons. If you wanted to help close to 1,000, that would take almost a year. So do we go on hiring spree to get as many professional 3D designers as we can to fill this valley of no designs? A non-profit organization called Enable actually is really close to that. With a community of 7,000 members, they were capable of producing and delivering 1,032 hands in year 2015. They're actually planning to double this amount to 3,300. If they continue doubling every year, even then it won't be enough to actually cater to the global need. So we know that even 50 million designs couldn't be done by a professional designer because it's just way too long to process one case. So how do we approach this? How do we effectively help everyone in need while keeping the cost low and the process available? The solution was very simple for us. We had to critically decrease the time needed to process one case. And therefore, we needed something more efficient than human labor to do this. What is more efficient at digital tasks than human? Many would argue that's a smartphone. An interesting idea presented by Peter Diamandis, a co-founder and executive chairman at Singularity University. He predicts that from 2.6 billion internet-connected smartphones right now, it will grow to almost 5 billion by year 2020. Likewise, 3D printers will grow at least fourfold by the time reaching 4 million printers globally. Why is this important? This means that the availability of 3D printers and the availability of smartphones is not going to be a problem in the future. So why smartphones? Because smartphones are capable of processing 3D data. And what's more important, they can also make 3D scans. To illustrate how easy it is to make a 3D scan, I have asked my colleague Fritzes to join me on stage. In about 60 seconds, Fritzes will make a 3D scan of my hand. And this scan will have sufficient detail to actually create me a prosthesis. He's using an iPad with a small add-on. The small 3D scanner works by projecting an infrared laser pattern onto my hand. It cannot be seen with the naked eye, but the iPad's camera can pick it up and make it into a 3D model. Thank you, Fritzi. Let's take a look. In just about 60 seconds, we have a 3D scan of my hand. In the near future, this will be possible on any smartphone without the need for external gadgets. This means that if in the future, 1 out of 100 people will make a 3D scan of an impaired person, we will have all the 3D scans we need to help everyone. But what can be done with 50 million scans? It's an impossible task for a human to process this. Remember that I mentioned we need something more efficient than human labor to battle this. With this idea in mind, for the last 1.5 years, my team and I have been working on artificial intelligence software. Having seen how 3D scanning can help in the process of 3D modeling a digital prosthesis, we were looking for ways how to make these two things work together. What is more, we figured that with help of artificial intelligence algorithms, we could effectively replace much of the human input needed to do the repetitive tasks. To achieve this, we worked together with 3D design professionals, with prosthetic doctors, to implement their know-how already into the code. The artificial intelligence algorithm then learns from each new case, thus making the prosthesis better and decreasing the time needed per modification. In the current stage of development, the software can take a 3D scan as the main input, even a scan from a mobile phone, and adjust it around the prosthesis design, basically adjusting it to the 3D scan anatomy, eventually creating a customized prosthesis tailored to everyone individually. Finally, we send the 3D design to a 3D printer right away from the software. The important bit, however, is that this happens with little or no human input. We will be able to teach anybody of you to use this software to process a single prosthetic in 15 minutes or less, and thus excluding the need for professional 3D designers. And the best part about this, it already works today. Let us look back at the problem. We lack professional designers' time to prepare a prosthetic for everyone. To be more exact, we need to be able to send over 50 million designs to any 3D printer in the world. While this could be a job 3D printers can certainly handle, no army of 3D designers could do this. Therefore, we actually leave the job for any one of you, anybody who has a smartphone together with the smart software. Just a few weeks, we used the same principle on the Latvian Paralympics team member, Polina. Polina currently is Paralympics fencer, currently one of the best in the world. But even for her, it is really hard to find the exact back support that she needs. We modeled and 3D printed her an individually fitted lower back brace, and in the modeling process, there were no medical professionals or professional 3D designers present. These are the sore moments when I look back at how I came to work with 3D printing and artificial intelligence software. Just a bit over 3 years ago, I was on an experience exchange program sitting in an office in downtown New York. I was distracted from the ever-rewarding process of brokering non-banking debt by watching a YouTube video explaining 3D printing. I was completely mesmerized for weeks. I was using my morning and evening commutes to dwell over endless ideas of how else we could be using 3D printers. Never did I imagine, though, that I would be helping people like Richard, Reinis, and Polina. It is mind-boggling to think that financial analysts like me could be using it, could be doing it. What is more, not only my profession, but also my location doesn't matter anymore. It actually doesn't matter whether that's me doing it, because anybody of you could be preparing 3D models and sending them over to any 3D printer in the world. Much like Polina, when she leaves for the Paralympic Games, will be able to take a 3D model of her brace with her, and in case she breaks the back support, she'll just have to find the closest 3D printing shop and make a new one. Smartphones with 3D scanning functionality, intelligent software, and 3D printers, these will be the three cornerstones of individualized device and wearables production in the future. Where I'm going with this is that next time, when Richard grows out of his prosthesis in 1 year, his mom will not be coming to our office anymore. She will take her smartphone, open an app, do a quick 3D scan, prepare some modifications, and send the design to the closest 3D printer available to her. I don't think George Lucas had this in mind either, but I truly hope that in the future, any person in need will be able to receive artificially fitted and customized prosthesis, just like Luke Skywalker did when he lost his hand in the sword fight. Thank you very much.